Did you know that landing a spacecraft on Mars requires surviving temperatures hotter than a blowtorch and speeds over 20,000 kilometers per hour? And that's just entry. SpaceX is tackling these mind-bending challenges head-on with incredible tools you've probably never heard of. So, how will they do it? And what makes it so risky? Let's find out. Imagine descending into an alien world where the atmosphere is so thin it barely slows you down, and the surface rushes toward you as your spacecraft swelters under temperatures hotter than molten lava. That's what it takes to land on Mars. Unlike Earth, where gravity and a thick atmosphere can work in your favor during re-entry, Mars offers no such luxury. Its tricky combination, nearly non-existent air resistance and just over a third of Earth's gravity, makes it one of the toughest planets to land on. And yet, SpaceX is determined to rewrite what's possible. First, let's break down the challenges. The Martian atmosphere is roughly 100 times thinner than Earth's, which might not seem like a big deal at first. But when you're hurtling toward the surface at hypersonic speeds, that thin layer works against you. Parachutes, the go-to solution for slowing down spacecraft on Earth, are barely effective on Mars. If you've seen footage of Earth landings, massive parachutes provide most of the braking power as capsules descend, using the dense air to slow their fall. On Mars, there's simply not enough air to grab onto. This leaves engineers to rely on a mix of other solutions, like retrothrusters or air braking systems, both of which have limitations of their own. To put it in perspective, compare this to the Moon. Even though the Moon doesn't have an atmosphere at all, controlling a lunar landing is arguably easier than Mars. That's because spacecraft don't have to deal with the chaotic transition between atmospheric entry and surface descent. On the Moon, all braking is done with thrusters in a straightforward vacuum environment. Earth, on the other hand, is easier thanks to its thick atmosphere catching parachutes, making the descent more, well, predictable. Mars is stuck somewhere in the middle. Its atmosphere is just thick enough to cause problems during entry, but far too thin to reliably help you land safely. Now, let's talk about the infamous 7 minutes of terror. This phrase describes the critical entry, descent, and landing (EDL) phase on Mars. A spacecraft entering the planet's atmosphere travels at speeds upwards of 20,000 kilometers per hour. By the time it reaches the surface, it must slow to almost zero. The stakes couldn't be higher. The spacecraft only has a 7-minute window to execute an intricate choreography of heat shielding, precision maneuvering, and braking, all while battling the thin atmosphere, gravitational pull, and unpredictable weather conditions. And here's the kicker. There's no real-time control from Earth. Thanks to the communication delay of about 15 minutes, the entire sequence has to be automated. NASA's Perseverance rover, for example, relied on a series of perfectly timed steps, from shedding its heat shield to deploying a sky crane to land safely. But that's a 1-ton rover. Now imagine landing something as massive as SpaceX's Starship. This is where SpaceX is pulling out all the stops, designing Starship specifically to overcome these challenges. Unlike traditional spacecraft, Starship is far larger, fully reusable, and has to carry not just equipment, but humans and supplies for an extended stay on Mars. One of its standout features is its stainless steel heat shield. Typical spacecraft use materials that burn up during re-entry, but Starship's heat shield is designed to withstand the extreme temperatures and be used again and again. Made from heat-resistant tiles and stainless steel, it dissipates heat more efficiently. That's crucial, given the unrelenting conditions of Martian entry. Precision is another factor that sets SpaceX apart. Starship incorporates advanced navigation systems capable of pinpoint landings, something past Mars missions couldn't achieve. For example, earlier landers often relied on wide landing ellipses, essentially large areas where they'd aim to touch down. But Starship is gearing for pinpoint accuracy, its engines and onboard computers working in sync to adjust its trajectory in real time during descent. The ability to land precisely in a pre-selected spot on Mars could make or break a mission, especially when considering the need to link up with future bases or resources. So far, no spacecraft designed for reusability has attempted what Starship is planning. While re-entry vehicles like the Space Shuttle were reusable, they operated exclusively within Earth's atmosphere. Starship aims to land and be reused on Mars, which introduces a whole new level of complexity. Its unique belly flop maneuver during descent, a horizontal glide followed by a rapid flip to vertical, is designed to maximize drag and optimize fuel usage for landing. This move is key for navigating Mars' atmosphere and conserving resources for the journey back. SpaceX's approach isn't just about surviving the landing, it's about surviving it in a way that sets the stage for more than a one-off trip. The goal is to build a system where spacecraft can land, relaunch, and do it all again. This kind of reusability is critical to making Mars missions viable in the long run, and means Starship has to not only land safely, but also protect its engines, structure, and systems from damage during the process. With this in mind, SpaceX is testing materials and components rigorously, learning from each iteration to get closer to a design that works not once, but sustainably. So, how does Starship take these cutting-edge ideas and actually execute them on a Martian mission? What else needs to fall into place for it to thrive on Mars's surface? Let's take a look. What if the future of Mars exploration isn't just about touching down, but about creating a system where we can land, refuel, and launch again, all with the same spacecraft? That's exactly what SpaceX envisions with Starship. Designed not as a one-time lander, but as a fully reusable spacecraft, Starship is unlike anything we've ever seen. It's not just about reaching Mars, it's about redefining what's possible once we get there. Starship is massive, standing at 120 meters tall when stacked with its super heavy booster, making it the largest spacecraft ever built. And its size isn't just for show. It's built to carry over 100 tons of cargo or passengers, significantly more than any past spacecraft. SpaceX designed it with Mars in mind from the start, ensuring it can withstand the harsh realities of interplanetary travel and the tricky physics of Martian landing. But not everyone is convinced. Critics have questioned its scale, its complexity, and whether reusability will prove practical in such an unforgiving environment. After all, most missions to Mars have been about minimizing mass and complexity, while Starship does the opposite. Let's tackle the doubters by looking directly at Starship's standout features. Take its stainless steel design, for example. At first glance, stainless steel might seem like an unconventional choice for a spacecraft. It's heavier than the aluminum and carbon composites typically used, but there's a solid reason for it. Stainless steel can handle higher temperatures without losing strength, crucial during Mars entry. When Starship plunges into the atmosphere at hypersonic speeds, its heat shield must endure temperatures as high as 1,500 degrees Celsius. Instead of relying solely on ablative coatings that burn up, Starship's tiles and steel frame are designed for repeated use, saving costs over time. It's a system designed to weather the journey, land intact, and be ready for the next mission. SpaceX isn't just tackling the challenge of landing on Mars, it's laying down the framework for something much bigger: the possibility for humans to exist as a multiplanetary species. Starship isn't simply a spacecraft. It's part of a larger system designed to make Mars missions not only possible, but sustainable. The future it envisions isn't decades away. It's unfolding right now. The real question is, will Starship mark the turning point for humanity's age of exploration, or will Mars remain beyond reach? Either way, one thing's clear. The journey to Mars is no longer a dream. It's happening in our lifetime. Stay tuned.